Okay, so just a scheduling reminder. Today and Monday, so of course, what is Monday? The 13th, will be the same lecture. Jesse, is Clayton still out of school on Monday, or did you guys change the schedule? Oh, no? Okay. The schedule I gave you guys is having an in-service day on Monday. If you're in school, it won't make a big difference. When you come to class, bring some work with you. We'll do pretty much the same lecture. I might do different examples. So if you want to see it again, you're welcome to. Otherwise, you're welcome to just sit there and do homework while we're going through it. Because today, Mauston is out, and Monday, Flambeau is on spring break. So we're going to repeat the lecture just so that nobody has to log in from home. Hopefully, Flambeau gets logged in here soon so I can explain it to her what's going on. So anyway, where we left off on Wednesday, we were talking about dilutions and how it fit in with our solution concentration formula. Well, dilutions, if you looked at a 1 in 6 dilution, if you recall, that was saying that ratio of 1 to 6, the 1 represented the parts of serum. Remember, serum is just the active ingredient, whether it's a medication, an antiseptic, vitamin supplement, electrolytes, or even just another solution that's more concentrated. And then 6 was the total parts. That's how much we had once we're done mixing it, once we're done diluting it. And as we've said, this dilution, doing it in this way is very important because then this calculation applies to a lot of other things that we would do. One of the things we looked at was, how much morphine should be used to create 180 milliliters of a 2 in 15 dilution. So we have that 2 in 15, it's a ratio. And the 2 represents the amount of serum. In this case, the serum's the morphine, so we're going to go ahead and just put morphine there. And 15 is the total solution. Well, up above, the 180 milliliters is a little vague, but it's saying 180 milliliters of the 2 in 15 dilution. So what that is saying, whenever we say we want a certain amount of this dilution, that is telling us that that is the total amount after it is diluted. So that 180 milliliters does represent the total solution. And then, of course, we cross, multiply, and divide. 2 times 180 divided by 15, I believe that gives us 12, but I'm going to go ahead and double check that calculation. 2 times 180 divided by 15, actually, she gives 24, 2.4, 24, sorry. I punched in, I missed a 0 there, so it is 24 milliliters. So we would take 24 milliliters, and then if we wanted to finish that, 24 milliliters of morphine, I cannot say for certain that it would be 180 minus 24 or 156 milliliters of sterile water. The reason is when the morphine dissolves into water, it tends to hide between the water particles, so it doesn't increase the volume in an additive way like that. So we would fill with normal saline, NS, or sterile water, to 180 milliliters. So you'd put the morphine in the solution first, and then you would fill stirring so that the morphine dissolves as it's able to with NS to 180 milliliters. So again, this is a case where we can't necessarily just subtract. A case where it is additive is when it's already a fluid that we are mixing. And we looked at this in a case where we exceed the meter. So we test a blood sample, doing a blood sugar test. So for a blood glucose test, the initial reading with pure blood gives us an error or a message saying that that limit is exceeded. So what we're going to do then is we're going to take 400 microliters. So we either do it like that, microliters, or MCL like that for microliters of blood mixed with 1 milliliter of neutral solution, or normal saline. So now we test the diluted sample and it gives us a result of 198 milligrams per deciliter of blood glucose, of glucose in that blood sample. So we need the true reading. Well, to get the true reading, or the true level, the first thing we have to determine here is what dilution was performed here. And so the dilution, remember, is always serum over total solution. And in this case, the serum is the blood. So we had 400 microliters of blood over, now it's very important that we make sure this is total solution here. We had 1 milliliter of water, but we added that to the 400 microliters of blood to get a total. Now the first thing we have to do here is change microliters to milliliters. 400 microliters is just 0.4 milliliters. So then this is 1 milliliter plus 0.4 milliliters on bottom. So we have 0.4 milliliters over 1.4 milliliters. So now we have to reduce that to get our dilution. Actually, we don't even have to reduce it to a dilution. We can just leave it, just canceling out the milliliters. And remember, the diluted level, the diluted reading here, which is the 198 milligrams per deciliter, is the smaller number. So it has to go with the smaller number of the dilution. So it's going to go on top. So 198 milligrams per deciliter. And we cross multiply and divide. So 1.4 times 198 divided by 0.4. Giving us 693 milligrams per deciliter. So that is the true level in the blood of that patient. Then the last thing where we left off, we were looking at that solution formula, solution concentration formula. Where we had well, the formula is the amount of serum equals the concentration, which is just a percent as a rate times the total amount of solution. And we saw this last unit as well. Let's say we have 500 milliliters of 32% solution. Well, that means then the amount of active ingredient we have is 0.32 times 500 milliliters. And I believe that comes out to 160 milliliters of active ingredient. Or serum, as we've been referring to it. So then we looked at, okay, what dilution is required? To dilute 240 milliliters of 16% solution to 12%. So here, this process is important to start with what we are looking for, or what we're starting with, I should say. We are starting with 240 milliliters of 16% solution. So let's look at how much active ingredient or how much serum we have here. So it's going to be 16%, 0.16 times 240 milliliters. So 16% times 240, 0.16 times 240, gives us 38.4 milliliters of serum. When we do a dilution, we don't add any active ingredient. The only thing we add is a neutral solution, sterile water usually. So then let's look at what we're going to end up with, or what the result is going to be. In the result, we will still have 38.4 milliliters of the serum. But it's now going to be a 12% solution times X amount. We need to know what that new amount is going to be. So here, we solve for X by dividing by 0.12. 38.4 divided by 0.12 gives us 320. So this is 320 milliliters that we'll have of total solution. Now to do the dilution here, we have to shift a little bit. In the dilution, the serum is going to be the 16% solution, the more concentrated solution. We are starting with 240 milliliters of that. And then our total solution is the resulting amount after we've diluted it, which is going to be the 320 milliliters. So now here the milliliters cancel out, and we have to reduce 240 and 320. Now both of those will divide by 80. 240 divided by 80 is 3, and 320 divided by 80 is 4. So this is a 3 in 4 dilution. So one of our big topics of today is, where's the shortcut? There has to be a shortcut rather than going through this whole formula every time to figure out what the new amount of the solution is going to be. And there's a relationship between this dilution and the concentration of the formula. Notice here we went from 16% to an ending amount of 12%. If I put those percents in a ratio, with the ending amount on top, the smaller amount on top, and the starting amount on bottom. And I reduce that ratio. Of course, the percents cancel out. Both 12 and 16 divided by 4, giving me a 3-to-4 ratio. Well, that's just our dilution. So in this type of a problem, the ending concentration, the ratio of the ending concentration to the starting concentration is equal to the dilution ratio. So if I ask what dilution is required, to dilute 45% solution to 10% solution. I don't have to do a fancy calculation using that solution concentration formula. I can simply use the percents to create the dilution. So the ending concentration over the starting concentration. The ending concentration is going to be 10%. We started with 45%. The percents cancel out, and both 10 and 45 can be divided by 5. 10 divided by 5 is 2. 45 divided by 5 is 9. This is a 2 in 9 dilution that would be required. If I ask how much neutral solution, how much normal saline or whatever needs to be added or should be added to 360 milliliters of 18% solution to create, let's go with 12% solution. Actually, yeah, that'll be fine. Well, we can find our dilution required. That required dilution, remember, is the ending concentration over the starting concentration. And that ending concentration is going to be 12%. Starting concentration is 18%. The percents cancel out, and both 12 and 18 can be reduced by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3, giving us a 2-to-3 dilution. So now that 2-to-3 dilution, remember the 2 represents the serum. In this case, that's the concentrate, or the 18% solution. The 3 now represents the total amount, or the total solution once we're done. So when we're trying to find the amount of saline here, the normal saline to add, well, the 2 represents the amount of concentrate. That is the 360 milliliters of the 18% solution. But we're not looking for the total solution. We're looking for the amount of saline. So we could put 360 milliliters here, cross multiply and divide to get the total amount of solution, which would be 540 milliliters, and we could subtract. 540 minus 360 gives us 180 milliliters of normal saline. It should be added, or sterile water. Or we could adjust this ratio so that we have our concentrate, the 18%, to the amount of NS being added. And here, the amount of concentrated solution we have is still 2 parts, but the sterile water is 3 parts minus the 2 from the concentrate, so just 1 part. And now we can put the 360 milliliters on top. And if we cross multiply and divide, 1 times 360 divided by 2 gives us 180 milliliters. So notice, same result, 180 milliliters of sterile water. It's just a matter of how you prefer to approach it. So using that dilution ratio is a very powerful tool. We might be asked to find the new concentration after a 21% solution is diluted 2 and 7. So let's go through the whole process here and then come back and look at how the dilution ratio can be a shortcut. So we start off with 21% solution, but it doesn't give us an amount. So we can pick an amount. It really doesn't matter what the amount is. The dilution ratio will be the same. The new solution will be the same. So let's just pick an easy amount. Let's just choose that amount to be 100 milliliters. So the amount of serum is equal to the 0.21 for the 21% times that 100 milliliters. That's going to give us a serum amount. 0.21 times 100 is 21 milliliters. Now we are going to do the 2 in 7 dilution. Now remember, the 2 in 7, the 2 is the serum or the concentrate. In this case, the concentrate is the 21% solution. And then the 7 is going to be the total solution after we've diluted it. So remember, we said we were starting with 100 milliliters. So we cross multiply and divide. 7 times 100 divided by 2 is 350. So we're ending up with 350 milliliters of total solution after that dilution. To find the percent then, we go back to our dilution formula. We know that we still have 21 milliliters of serum. We haven't added any serum. We've only added sterile water. So we have 21 milliliters is equal to whatever the new concentration is, that's our X, times our new volume of 350 milliliters. So to solve for X here, we're going to divide by 350 milliliters. So the milliliters cancel out. 21 divided by 350 gives us 0.06 equals X. That's a concentration of 0.06 or a 6% solution. So again, that wasn't terrible to do. We could find that new concentration using that solution concentration formula. But there's shortcuts. We don't have to go through that amount of work. Remember, this is a 2 in 7 dilution. That's going to be equal to the ending concentration over the starting or beginning concentration. And we started with a concentration of 21%. So if we cross multiply and divide here, 2 times 21 is 42, divided by 7 is 6. The ending concentration is 6%. So way quicker to just use that dilution ratio to adjust what the percent of the solution is going to be. So a consequence of all this is another way of adjusting the concentration of a solution, and it is called a concentration adjustment formula. Or sometimes called change in concentration formula. And all it does is it says that this amount of serum is the same before and after. So the amount of serum before a dilution is equal to the amount of serum after the dilution. And the formula, remember, the amount of serum before is the concentration times the volume. So we're going to go C1 times V1, where C is the concentration before, C1 is the concentration before, V1 is the concentration after. That gives the amount of serum or active ingredient before it's diluted. And that has to equal the concentration after, which we're going to call C2, times the volume after, which we'll call V2. When we get into the algebra section in Unit 4, we'll refer to this as what's called an inverse relationship. If the volume gets larger, the concentration has to get smaller because the total amount of serum or active ingredient has to stay the same. So here, let's say we're going to start with, well, let's do this. Go the simpler version. Find the concentration spell that correctly. Concentration after 240 milliliters of 18% solution is diluted to 720 milliliters. So the amount before is this right here. The amount after is this, we just don't know the concentration. So before this dilution, we have 18%, 0.18 times 240 milliliters. After the dilution, we don't know the concentration, so I'm going to put X in there, but we do know it's diluted to 720 milliliters. Now, I left the milliliters out just to avoid complicating the formula. And we multiply 0.18 times 240. Gives us 43.2. Equals X times 720. And then we have to divide by the 720 to get X. So 43.2 divided by 720 gives us 0.06. So X equals 0.06 or 6%. The new solution will be a 6% concentration. Now, because this formula has a concentration on each side, I don't actually have to change it to a decimal like this. I could have left that as a percent. I could have did 18 times 240 equals X times 720. And if I left it that way, when I multiply 18 times 240, 4,320 equals X times 720. And then dividing by 720, 4320 divided by 720 is just 6. So what I get here is actually the percent. So I can do it either way, I just have to be careful. If I started with the percent here, the result I get is the percent. Or over here, where if I start with it as a as a rate, as a decimal, the result I get is a decimal and it has to be converted back to a percent. But the formula will work just fine either way. So if I know the beginning and final amounts, the initial volume and the final volume, like I did here, going from 240 milliliters to 720 milliliters, finding the new concentration is pretty simple. Actually doing a dilution is a little bit more complicated here. If I ask how much neutral solution should be combined with 300 milliliters of 60% solution to create 15% solution. So the setup using the formula is still pretty straightforward. We have the beginning or the starting amount, and we have the ending amounts. The starting amount, we have 300 milliliters of 60% solution. So 60%, I'm actually just going to leave it as percent so I don't have to convert. So 60%, or just 60, times the amount of 300 milliliters equals 15%. Now, since I left the 60 as a percent, I have to leave the 15 as the percent, times X will be my new amount after the dilution. So 60 times 300 is 18,000 equals 15X. And now solving for X, we just have to divide by 15. So 18,000 divided by 15 is 1,200. So X equals 1,200. So that is saying is the ending amount is 1,200 milliliters. But we weren't asked for the final volume. We were asked how much neutral solution should be combined with it there. Well, the volume went from 300 milliliters to 1,200 milliliters. We didn't add any serum. We only added neutral solution or sterile water. So the amount of NS that is added there is the final amount of 1,200 milliliters minus the starting amount of 300 milliliters, giving us a difference of 900 milliliters. And that difference, of course, was made up with NS, sterile water. Well, that covers pretty much everything we needed to do today. So I'm going to let you out a little bit early. Our homework. Scroll down the page over here. Is going to be pages 134, 1 through 11, the odds, and page 138, 1 through 11, the odds. And as I mentioned on Wednesday, at this point, make sure you're doing a few more of the problems than normal, because this is stuff that's going to be a little bit new to you, and they're going to throw some twists at you in the homework. So make sure you're doing more of them. Okay, well, with that, I'll let you out of here. You have a great weekend, Jesse. We'll see you next week. Like I said, if you come in on Monday, great. Otherwise, we'll see you Wednesday.